Negative binomial distribution. Negative binomial distribution answers the question negative binomial distribution answers the question: a coin is tossed repeatedly until head comes up for the sixth time. What is the probability that this happens on the 15th toss? So this is also just like a geometric distribution where it tells the number of trials needed to get the first success. The geometric distribution is the number of trials needed to get the number of trials needed to get the first success, while negative binomial is the number of trials to get the number of trials to get the rth success. If we are interested in the second success, then r is equal to 2. Binomial distribution, on the other hand, is the number of successes in fixed number of trials. Fixed number of trials we call as n. In negative binomial is the distribution of number of trials needed to get a fixed number of success. We call that an r. And here the number of trials is the random variable, which we call as x. Here the number of trials is fixed, which is n, and number of successes is the random variable. So it's a big difference between negative binomial and binomial distribution. It has to be just like other Bernoulli trials, it also has to be independent trials, and each trial result in two exclusive outcomes: independent trials, and each trial results in two exclusive outcomes. They're going to be success, which is p, and failures, which is probability is going to be 1 minus p. X is the random variable that represents the trial number x in negative binomial. X, which is this number right here, is the random variable that represents the trial number of the rth success. Now, in order for rth success to occur on the xth trial, rth success to occur on the x trial, we need a couple of events to occur. First, x minus 1 trials must occur. That results in r minus 1 successes. And we can calculate this with the binomial formula, which is x minus 1 is the number and the number of successes is r minus 1. Then the probability r minus 1 and 1 minus p is going to be x minus 1 minus r minus 1, which is basically just n minus x. So this is just a binomial formula to calculate that. And then the second thing that will happen is the xth trial must be a success and which has the same probability as P. To get the rth success, on xth trial, we simply multiply these probabilities together. So all we are doing here is P times, that is the rth success, and r minus 1, P r minus 1, 1 minus P x minus 1 minus r minus 1. Then with some algebra we can come to the PDF of P of x is equal to little x, x minus 1, r minus 1, P to the power r, and 1 minus P x minus r. This is the PDF of the negative binomial distribution. Now if we need to list what values x can take on, the mean of negative binomial distribution is r about P, and sigma square is equal to r 1 minus P upon P square. These are also important formulas for negative binomial distribution. Now let's do a quick question. So the question is, a person is conducting telephone surveys and he must get 3 more completed surveys before his job is finished. In one dial, there is 9% chance of getting an adult of getting a completed survey. Now the question is, what is probability that third completed survey occurs on the 10th trial? So this is a binomial distribution problem, and we're going to solve it with the binomial formula, which is going to be P of x is equal to little x, which is 3. So here we have the formula for binomial distribution is x minus 1, r minus 1 probability times r, 1 minus probability times x minus r. Actually, there has to be a p also in it. There has to be a p also, because that's just you multiply that with the p, and that's the formula. So actually that's not right. This is r minus 1 and this is p, so this p's go, that's why p's go away, so you don't need a p here. This is the formula. So what is x here? X here is 10, which is going to be 10 minus 1, and r is the 3 trial, so that is 3 minus 1, and the probability of success is 0.09. So then it goes to the r is 3, and 1 minus probability is 1 minus 0.09, and there is x minus r, which is 10 minus 3, which is going to be 7. So which is going to be 0.01356. And why is x 3? So what is x? X in this case is the trial number it's the random variable that represents the trial number for the rth success. So that random variable is the x. P of x is equal to x, where x is the little x, which is 10. So x is 10 is what we want to know, and so that x goes here is the number of, that's negative binomial. Negative binomial is number of successes in a fixed number of trials. So fixed number of trials, the trial number is fixed, which is 10, and you want to know how many of them would be third completed successes, so third success. So that is why R, 3 successes in 10 number of trials, so that goes here, and each has the probability of success of 0.09. And what is the mu? So mu will be R upon P, which is 3 upon 0.09, so that will be 33 half. So on an average we have to make 33 calls. On average he has to make 33 calls before he is done for the day.